Welcome to Lecture 5. After about 27 minutes warming up in previous lectures, we want to dive into EIGRP. In this lecture, I intend to describe EIGRP history and EIGRP process for you. Therefore, I expect you after this lesson, you could describe EIGRP history and describe EIGRP process. Let's start our today's mission. Cisco introduced EIGRP in 1990s. There are three waves in the history of routing protocols. In the first wave, we have RIP version 1 and EIGRP. RIP version 1 is a standard routing protocol and EIGRP is or was a Cisco proprietary routing protocol, which means that you could use this routing protocol only in Cisco routers, not the routers of other vendors. The second wave includes RIP version 2, OSPF, and EIGRP. These routing protocols were faster and have more capabilities than the predecessors. But EIGRP is still a Cisco proprietary. Again, you could use EIGRP only in Cisco routers. And the third wave include OSPF version 3, RIP-NG next generation, and EIGRP v6. By introducing IP version 6, routing protocols should have changed. Therefore, OSPF, RIP, and EIGRP adapt themselves with IPv6 so they could route IPv6 too. Therefore, as I mentioned, we have three waves of routing protocols. First wave, second wave, and third wave. I want to emphasize that EIGRP, EIGRP, and EIGRP v6 are all Cisco proprietary originally. And it was the negative aspects of EIGRP, because if you want to use these protocols, you have to buy Cisco routers. Many customers may not want to buy all of their routers from Cisco, or assume that you are an ISP and you are confronting with different customers and different routers. You could not force your customers to use Cisco routers. Therefore, you lose your customers. So Cisco made a decision in 2013 and deliver EIGRP secrets to IETF and introduces the related RFC information. Therefore, nowadays, other vendors could use EIGRP and implement it in their products. EIGRP process is very simple. There are only three steps: neighbor discovery, topology exchange, and choosing routes. First of all, before EIGRP routers could trust each other and send their topology information, they should become neighbors. This process is called neighbor discovery. EIGRP routers send some hello packets, and after that, if everything is okay, they become neighbors. So after this phase, a neighbor table is formed or updated. After this neighborship is formed, routers send their topology informations to each other. So after this phase, the topology table of each side is formed or updated. Now it's the time for acting the routing protocol. EIGRP, based on the topology table information, should calculate the metrics and among the metrics, choose the best one and put it in the routing table. Therefore, after this phase, our routing table updated. As you could see, each EIGRP neighbor has three tables: neighbor table, which maintains the neighbor router's information; topology table, which maintains the topology information of the network; and routing table, which maintains the routing information. Just for shortening our lecture, in this lecture I only describe you the neighbor discovery phase and leave the other phases for the next lectures. Before I start to explain you what's happening inside EIGRP neighbor discovery process, I want to introduce you EIGRP Packets. EIGRP uses 5 basic messages to do all his jobs, not only neighbor discovery. These messages are hello, update, query, reply, and acknowledgement. The question is how routers understand the type of the message. Inside EIGRP header, there is a field which is called opcode. Each of these messages have their own opcode unique number. For hello, it is 5. For update, it is 1. For query is 3. For reply is 4. And for acknowledgement is 2. So these messages are identified by their opcode. In EIGRP process, everything starts with hello messages. When you configure your routers to start EIGRP and enable the related interfaces, router starts to send hello messages on these enabled interfaces. If the other side also configured with EIGRP and everything goes well, neighbor discovery will success. Let's see what's happening inside this process. For creating and maintaining neighborship states between EIGRP routers, hello messages must be sent periodically. This period is based on a timer which is called hello interval. Hello interval varies for different networks. By default, networks are divided into two groups of 5-second hello interval and 60-second hello intervals. And you could see different networks of these groups. I put these slides in the curriculum of the course so you could write it now or use it whenever you want. Assume that we have two routers. These two routers are EIGRP neighbors and send periodically the hello messages to each other. The question is, if this link is down and hello messages could not be sent, furthermore, how much time these routers should wait and keep the other one in their neighbor table? The answer is another timer, which is called hold interval or hold timer or hold time. By default, the hold interval or the hold time is 3 times of hello interval. So for these networks, the hold time is 15 seconds, and for these networks, the hold time is 180 seconds. Keep in mind that you could change these intervals and set them manually, but if you change the hello interval manually and, for example, change this from 5 to 10, this equation is not maintained by default. I mean that if you change it into 10, the hold time would not change into 30. And if you want to maintain this equation, you should change the hold time respectively and change it into 30 manually. I capture a hello packet in Wireshark and GNS3 and I want to show you this packet. This is a sample hello EIGRP packet. First of all, let's see the destination of this packet. As you could see, it's a multicast address 224.0.0.10. This is a multicast address which is reserved for EIGRP in IPv4, and in IPv6 this address is FF02A. I will show you this when I configured EIGRP for IPv6. And you could see different fields of EIGRP header. This is the opcode which I told you about it in the previous slide. The neighborship between two EIGRP neighbors are formed if 4 parameters are checked and passed. The first parameter is the IP address of the source and the destination. If two routers want to be neighbor, their direct connected interfaces must be in the same subnet. For example, in my scenario, it is 192.168.2.1 and the other side is 192.168.2.2. So this parameter is checked and passed. The next parameter is the AS number, which you see this in the hello message. Both routers must be in the same AS or autonomous system. So if you put this interface in AS1 and this one in AS2, the relationship would not form. The third parameter is the K values. The K values, which you see there, K1 to K6, must be the same in two routers. Otherwise, the neighborship relation would not form. And the final parameter is the authentication. By default, EIGRP does not require authentication, and you could configure it without authentication. But if you configure authentication in your EIGRP parameters, this authentication must be passed to for creating the neighborship relation. So we have 4 parameters: the IP subnets, autonomous system, key values, and authentication. If everything goes well and the 4 parameters are checked and passed, 2 EIGRP routers would become neighbors, and the related information are stored in EIGRP neighbor table. You could see EIGRP neighbor table with show IP EIGRP neighbors command. If you are not familiar with EIGRP commands, don't worry, I will tell you these commands in the right time. First of all, I want to show you this process 1. This number is our AS number or ASN, which must be the same in 2 routers. This is our first neighbor. The IP address is 192.168.2.2. The interface which we see this neighbor's hello is fast Ethernet 1/0. The hold time is now 40 seconds if everything is okay, and this hold time is decremented to 10. New hello packets will arrive and it resets again to 15. The uptime is the time which this relationship is formed. The SRTT stands for a smooth round trip time, which is the delay between the updates and the acknowledge, and the RTO is retransmission timeout. I will discuss these 2 concepts in updates process. So you see a typical neighbor table. Before we end up our today's lecture, let's review a couple of notes. First of all EIGRP traffic is sourced from the primary address of the interface, and EIGRP does not build peer relationships over secondary addresses. Please note that. The second note is there are no limitations on the number of neighbors the EIGRP could support, but it depends on memory capacity, processing power, means your CPU, the amount of exchange information such as the number of routes sent, topology, complexity, and network stability. So if you want to design a big network and use EIGRP as the network routing protocol, please keep these parameters in your mind when you're designing your network. Now it's summary time. In this lecture, we saw that EIGRP was introduced in 1990s and become a standard in 2013. EIGRP process includes 3 steps: neighbor discovery, topology exchange, and choosing routes. We saw that EIGRP have 5 basic messages: hello, update, request, reply, and acknowledge. We saw that hello messages are sent periodically based on the hello interval, and if inside the hold time or hold interval no hello packets are sent, the neighbor state goes down and routers delete the related entry in their neighbor table. We saw that if 4 parameters, which were AS number, the IP subnet of interfaces, authentication if used, and key values are the same, the neighborship relation is formed and 2 routers become neighbors. And finally, we saw a typical neighbor table. I hope this lecture could help to improve your knowledge, and see you in the next lecture.